report today, just for a heads up. We are starting with number 11. Okay, take a look at number 11 on the second page, dimensional analysis.
Oh, it's fine.
Down the back side. We did number 10 class. We're supposed to do number 11.
I know I didn't get it. Alright, I didn't know that.
I believe you. I'm just saying.
Okay.
It's not that.
Alright.
The thing about number 11 is you need the conversion between mile and feet. Okay?
That's what stumped me.
What should you do if you don't know a conversion factor? What's the easiest thing to do? Google it. Type in 1 feet or 1 foot or 1 mile to feet, and it'll tell you 5,280 feet. Okay? So if you ever don't know a conversion, it doesn't matter for what. If you're baking cookies and you don't know how to convert from cups to ounces in a fluid, you can just Google it. Type in 2 cups to fluid ounces. It'll tell you. Okay, so no matter what, when I need conversions, you can always use Google. It will help. And some of the stuff you should know. So the first problem here, or the first part from number 11, said 50 miles per hour to feet per second. How should I write this? Who remembers from last time? Tell me, how should I write this?
50 m over h.
Now instead of m, what might I write? Because m is like meters now.
Miles.
So mi or mile. Very
Yeah.
good. Okay? Again, it's 1 hour down there. Remember, m is meters. So if you just put an m there, it can be a little misleading.
A little confusing.
We don't want to have any ambiguity. So we're starting with 50 miles per hour, and we're going to convert to feet per second.
So to get the feet, you would put 1 mile at the bottom, and then you would put 5,280 feet on top.
Good job, Emmett. Well done. Again, Emmett noticed right away, we are starting with miles in the numerator, and we want to get to feet, so we put miles in the denominator, and now they drop off.
You can do either
We-
way.
And what is it again? Is it?
You can do it either way.
Remember, multiplication is commutative, so you can convert to hours first. If you did that, that's fine. So if you did your hour conversion first, same difference, because we're going to multiply in the end anyway.
How did you get that number?
Okay, so again, if you don't know this number, if you don't know the conversion between feet and miles, you can either look in your textbook, it's in there, there are tables in the back, or you can just Google, type in 1 mile, then the word 2, and put feet, and it'll tell you exactly what conversion is.
And that's what it is
5,280.
for 50, sorry.
No, not for 50. 50 has nothing to do with it again. We are trying to figure out how many feet are in 1 mile. Remember, your conversion factors are really the number 1. Let me give one example that I didn't give last class. That might help us a little bit. If you had 2/3 plus, say, 5/6, you can't add those, correct? What do you need? So wouldn't you multiply this by 2 over 2 so that you end up getting a 6 down here? Isn't 2 over 2 just 1? So we're multiplying by a factor of 1, thus not changing the value. Same thing here. This is a factor of 1, believe it or not. Doesn't look like it because the numbers are so different. But there are 5,280 feet in a mile, so this is not changing the value of our original quantity. Okay? After that, we then have to go to our time. Want to help us with the first step here? Where? Top or bottom? Why? Good. Hours in the bottom, so he knows minutes are going to be in the bottom. What's going to go up top? Hours, because we want to get rid of the hours. They're done, and what'd you say the numbers were? Per 1 hour. Again, remember, the numerical value that's larger could be in the top or the bottom. It just depends on where the units are located. So you don't want to say, oh, it's always going to be a number up here and a 1 down here. We notice we have 60 down here, not a 1. Okay? And the next one? 'Cause we're not done just yet.
60 minutes or 60 seconds.
Say again?
60 minutes. Oh, no. 60 seconds. No, wait.
No, 60 seconds.
60 minutes.
1
over
minute.
60
1 minute over 60 seconds.
Let him try. Start over. Sorry, start over. We got minutes down here, we want to get rid of them, so where do we put minutes?
On top.
Okay. So seconds on the bottom, and now,
And then that's
1 minute.
60 seconds and 1 minute.
good. You're saying it backwards, that's why they're all commenting. All right. So there are 60 seconds in 1 minute. Cancel. Notice, what did I say to do at the end to check? Look at your final units. I see feet left over here. I see second left over here. So we're good to go. Now, what should we do finally? Helen?
You multiply all the numbers. and then
Nice.
you
Multiply
get-
across. What do you got, Helen?
Okay, I don't really know how to read it. I think it's like wait, let's see how many. Oh, 950,400,000.
Helen, these are in the denominator, though. You gotta
Wait, so
divide by
we're
those.
doing it, and then I just did feet per second. So we want to do feet on top of the seconds per bottom.
Correct. So whatever's up top, you multiply.
But why
Okay.
can't you just do it the same as miles per hour?
What do you mean?
Oh, and then at the end you divide.
Yeah.
That's the way it goes.
Like that. Okay?
I had a bit of a mishap.
It's all right. So look at your locations, people. Look at your locations. You see there are two 60s on the bottom. Okay, they have to multiply by each other. Emmy, you want to reduce for us?
Well, then it would be 264,000,
Over.
3,600.
Good. What can I do to make this easier on myself right away?
Get rid of the zero.
Good, good. It's exciting, apparently, to do this.
Zeros.
Now, I really don't want to leave it like that, okay? I want to actually have a numerical value that's not a fraction. So the last step, divided through. Okay, anybody got the number for the end here?
I'll do it. I did 73.3 repeating.
That's right, very good, Erica.
Okay, you're already trying to outshine the rest of us.
Okay? Now, let's make believe the answer asked for scientific notation. Even though for this, you probably leave it like that. If you did ask for scientific, what do you got, Eric?
It'd be 7.33 times 10 to the first,
Why is it first, Emmett?
because you'll have to move the decimal point over.
Good. Remember, we're moving this one spot to do this, and take a look. This number, to get from right here back to standard form, it's getting bigger, correct? Again, 7.33 to 73.3 is getting larger. Therefore, this must be positive. The number 1 indicates there's one movement of the decimal. Okay? All right, now let's look at a little bit of a tougher one. So what I want to work on, and I give you a worksheet. If you want to practice more, if you need more practice, there are 6 problems. We're only going to look at number 6 and maybe number 5 if we have time. We're going to start at number 6 though right now. So the other ones, if you need practice on, you can work on your own. I'm not requiring you to do it, but it's up to you to decide. And I'm going to make one change on the worksheet. So once you get the worksheet, listen for a second. I'm going to tell you something to change. So please, everybody look up. Change this to meters. You're going to see that they both say centimeters cubed. We're going to convert to meters cubed to make it a little tougher on us. Ooh, not much tougher. Okay, so again, number 6, change this right here in the circle in blue. Change that to meters cubed, please.
I'm on it.
All right, so I realized, and this is something that sometimes as a teacher you realize after teaching the same lesson several times, that in the other section when I taught this afterward with kilo to milli and milli to micro and stuff, I showed them another way to do it. Remember, I was like, let me think of another way to do it with you guys. And I thought of another way to do it, and then I recorded that. So if you saw the recording, it was a little bit different. And I'm going to do that today, and it might clear things up a little bit for those that were confused with kilo to centi to milli and that stuff. Okay, so it might look a little bit different, but I think it's a little bit easier. So, with that said, how many things are we converting first? How many things are we converting in this?
2.
2. Question? Yeah, change it on your paper. It says cm cubed. It says centimeter cubed. Change it to meters cubed, please. That's what I was saying on the bottom of the unit, okay? All right, so we have 2. Good. We're changing 2 things. Again, it does not matter which order we change them in. So, for the sake of this problem, we're going to change the milligram to kilogram first. and then we'll work on the cubic units because those are a little more complicated. Now, if I want to go from milli, which is a very small unit, to kilo, which is a very large unit, I should probably go back to my base unit first. So we should get rid of the milli and get to grams, and then go from grams to kilograms. Okay?
Wait, why can't you just do it all at once?
You can. But what's the conversion you're going to multiply by then? Then you have to figure out why is the 7?
7 times.
Why 7?
Because because killi is 7 times the number.
It's not, no. It'd be 6 actually.
Uh,
But I don't want you to memorize that, and I'm going to show you why in a second.
I
Okay?
just feel like the King Henry doesn't use
You can do that, that's fine, and I've heard that one before. But then that's memorization, and not really understanding. I'd rather you understand it than memorize it.
Okay.
And I'm going to show you something now that might clear it up a little. So we have 5.14 times 10 to the 4 milligrams per cubic centimeter, and this is a 1 cubic centimeter down here. It's a 1. All right, so I see that we're in milligrams, and I want to first go to grams. I'm going to do it in 2 parts. So if I want to get rid of the milligrams, where should milligrams go? In the bottom, good. In the bottom. How come? Cancel out, good. Cancel out. Now, I want to go to grams first. So let's put grams up top. Now this is where I deviated in the other class, or changed it a little bit. Here's what I told Bev, and afterward I realized this might be a little more clear. If you look at your prefixes, what does milli mean? What do we write down as a numerical value for milli? Not 100, not 1,000.
10,000.
10 to the negative third, it's 1,000. I'm sorry, I fixed 1,000. So, because kilo is 1,000, we're going to do that. So 10 to the negative third was the number for milli. Again, on our list of numbers, for milli we had 10 to the negative third. If that doesn't make sense to you, look back at your notes to make sure you understand. Because we had 10 to the negative third listed. So, what I told them to think about was this. If milli means 10 to the negative third, and this fraction is really 1, remember we're always multiplying by the number 1, then we need to replace here with a negative third to balance out the milli. Again, now we're going to go through this. Milli in our notes, we wrote down, milli meant 10 to the negative third. So this really means that I already have the 10 to the negative third down here. Even though you don't see it, it's there. The little prefix m means 10 to the negative third. And a minute ago we talked about how we're really multiplying by a fraction, 2 over 2, or a fraction that really means 1, like here. So what's really going on right now is that this fraction needs to be 1 over 1. So if there's a 10 to the negative third here because of the milli, there needs to be a 10 to the negative third here to balance it out. Again, I know it sounds weird, but 10 to the negative third is what milli means. And if we have a 10 to the negative third down here, we need to have one up here so that this fraction is really like 1 over 1. So this is not here numerically, but it's here with a variable. So we can leave that as a 1, because that's a 1, and this is really 10 to the negative third. This 10 to the negative third, which is represented by the little m, is also up here now. And this is like you're balancing an equation. Remember chemistry, you would balance 2 sides of an equation? Similarly, we're balancing the numerator and the denominator. Now, hold on one second question. Once we've done that, if we want to keep going to kilo, and I want to keep going for a second so you can see what I mean, I would put gram down here and kilogram up here to get rid of my gram. Now, what did kilo mean? Numerically, 1,000, or 10 to the positive 3. Again, kilo in your prefix chart meant 10 to the positive 3 or 1,000. So if there's already a 10 to the positive 3 up top because of the little k, we need to put a 10 to the positive 3 down below to balance out the k. It's not making sense because I can see empty spaces. Questions, Gary?
It's basically like having a line on top and bottom, but first we can show them. You don't have to write one because it's like a given, like they put the thing in front of it, right?
Yes, it's like,
Like, I don't know how to word it, but like it's like saying 1 over 1, right?
that's exactly what it's like, Gabby. That's exactly what it's like. The word kilo means 1,000. To balance that out, to make this 1 over 1, which is our goal, we need 1,000 down here as well. That's why there's a 10 to the third here.
Why couldn't we just say
You still have to memorize, you do. But I'm saying to know where to put these numbers. Remember last class? A lot of people were confused. Where does the 10 to the negative 3 go? Does it go up top? Does it go down below? How do we know which one to use? So if you can memorize the prefixes, which you should really do, from that point on, all you have to do is think about the fact that this is really 1 over 1. And milli and 10 to the negative 3 cancel. And kilo and 10 to the positive 3, they're canceling.
Is this basically a way like how you get over this? Like the side of the
Yeah, it's like what we did the other day, yeah. I'm just trying to show you the idea of balancing the top and the bottom as a different perspective or a different way to look at it.
oh, okay.
Okay.
It's the same thing.
It's the same thing as we did the other day. It's the exact same thing. I'm just trying to give you guys a better explanation of why you put, for example, this number here and you don't put it up here. Why is there only a 1 in the numerator? Because there's already a kilo here, and a kilo means 1,000. So we need to balance out this kilo, which means 1,000, with a kilo down here, or 10 to the third, which also means 1,000. Helen,
Okay, I understand this way, but like, my way, I can put it in
you can
so
do
much
it.
quicker.
That's fine.
I can still do that.
Absolutely.
Wait,
But
but
again, Helen, look, ready? Your way to do that, when we're converting from milli to kilo, it's 10 to the 6, right?
Yeah,
So here's the negative 3,
would be
here's the
negative
positive
6,
3.
right?
It would be negative 6 up top, yes, or positive 6 down below, which can be a little bit confusing as to which way to do that.
yeah.
You see what I'm saying? It could
I
be-
put it in 10 to the 6 kilograms over 1 milligram.
which is incorrect.
Wait, or,
If you're going to use it your way, Helen, the 10 to the 6 needed to be in the bottom. That's what I'm trying to explain.
no, but 10 to the negative 6 up top. 10 to the negative 6.
That's fine. You
Yeah,
said
that's what I
plus.
would have done. Oh, well, wait, I think a better way to like explain this is like there's, for every 1 kilogram, like kilogram, there's 1,000 grams.
That's what this says right
That's
here.
exactly what it's saying, but like,
It's-
that's so much easier to understand if you say it
Repeat
that
that,
way.
wait, what?
For
For
every,
every 1 kilogram, there's 1,000 grams.
say it one more time.
For every kilogram, there's 1,000 grams.
That's what
And
this
for every,
says.
and for every 1 milligram, there's 10 to the negative third gram.
That's hard to memorize though, besides the prefix though.
Yeah, but if you know those letters, then it's so easy.
And that's the key, guys. Again, you hear what Carol just said. If you know the letters, you have to know what the prefixes mean for this to work. It really will help you. A lot of you know that a kilogram means 1,000 grams, just from common sense, from prior knowledge. A lot of you know that, I understand. But this is not always so clear. The fact that there's 10 to the negative 3 grams in a milligram is not always so clear. Especially when you get to giga and when you get to tera, you're not going to always know that it's a million or a billion and such. So knowing the prefixes, 10 to the 6, 10 to the 9, 10 to the 3, will help you. And if you're having trouble with that, just make flashcards. Make a flashcard. On one side, write K-I-L-O. On the other side, write 10 to the third. On one side, write giga. On the other side, write 10 to the 9, and so forth and so on. And go through it in memorize.
You had to go from milligrams to grams to kilograms.
You don't have to if you don't want to. If you want to go right from grams to kilograms, that's fine, but then you need to know that it's by a factor of 10 to the 6, either in the denominator or 10 to the negative 6 in the numerator, which can be very confusing. There is a lot of room for error. What I'm trying to show you right now is a method that kind of eliminates that room for error if you memorize the prefixes. Again, this is much less room for error if you know every prefix. Okay? If you do it the other way, it's fine as long as you do it right. But there's a lot of room for error the other way. Okay? Some people might put the 10 to the 6 in the wrong spot. Some people, as Howard, don't take offense, but in the beginning,
I
said
don't
10 to
take
the 7. You know, that's a little mistake there. And that's going to cause some error along the way.
Would you rather, or like, do you think it'd be easier to memorize the actual prefixes or their order?
I just remember the order.
Personal preference.
Just write it out, that's
Yeah.
part of the thing.
I memorized the prefixes when I was younger, and it was easier for me. I never learned, what was it again? King
Doesn't usually drink chocolate.
Henry doesn't usually drink chocolate milk.
Yeah.
That only goes up to what? Million.
It goes
doesn't
from kilogram
include-
to milligram.
It goes from what?
Killy to milli.
Yeah, so that's the thing. That goes from killi to million, which is fine. Outside of
You
killi,
never learned that?
Out-
When we were like freshmen, Miss Myers like told me about like sex. I was like,
outside of kilo
what did she
is mega, after mega is giga, after giga is tera. Below milli is micro, below micro is nano. So that's excluding 5 prefixes. So to do that way is fine, but you'd have to remember the order, plus 5 more for prefixes. So personally, I would just remember the prefixes. And we're not going to use prefixes like deca or deci. They're not used a lot in physics. So what I explained to you the other day were the ones that you should memorize. So I would recommend doing it. Okay? Again,
This was in order, right?
yes. I gave you the order getting bigger, and then I gave you the order getting smaller, both. Okay? So look at your notes and check.
What happens at line 10 to the third after kilo? Like, is there 10 to the second, 10 to the first? Like,
10 to the second and 10 to the first, there are, but again, we're not going to use them. That's what I was explaining. No, because in physics, a lot of the time we use grams and kilograms. We don't use decagrams.
So what is grams in terms of
It's unit.
numbers? Oh, it's just
It's the base unit, really.
it's confusing.
We don't use kilograms. Grams is the base unit. One at a time, you guys are quiet. One at a time.
That's not representative.
No, exactly. It's not. Just like meter. Meter by itself is no number
So
represented.
how are you converting from like one thing to that?
Yeah,
That's what
so like a
confuses
gram.
me.
Okay, so here,
That's
again, if I didn't have anything, if I cover up this 1K and I cover up the 10 to the third, I'm left with G over G, correct? And a G over a G would reduce to 1. A gram over a gram. Now, 1K means 1,000.
1/10 to the
1K, look at the numerator alone, means 1,000, right? Just like in money. Ever seen money, they say, you know, I got 10 Ks. 10 Ks means 10,000 bucks, okay? So a K means 1,000. So this 1,000 here is being balanced with this 1,000 right here. Just like over here. If I cover up the 1M right here, and the 10 to the negative third, I have G over G. The M, lowercase, means milli, which means 10 to the negative third. So now these are balancing each other out. Okay? So every time you do this, you're going to convert to a base unit and then go on to the next unit if needed.
So basically, when you're converting to a base unit, you just like flip the numbers.
Yeah, in a sense. Sure. I can think of it that way. Gabby.
It's like kind of the same thing as on a base unit. Like on the homework, they gave us like a scientific notation thing, and then in like kilograms, and it converts to grams. How would we, like, what is the
You
decimal?
do it like this,
So-
and then you just like flip it.
So if it gives you, yes, exactly right. If it gives you kilograms, you said, right? If you were given, side note, if you were given some number like 20 kilograms and you want to convert it to grams, if you happen to know the answer, that's fine. It's 20,000. Because I know that there's 1,000 grams in a kilogram. But the conversion would look like the following. Put a kilogram down there, put a gram up top. Kilo means 1,000, so there's already 1,000 down here, so put 10 to the third up top to balance out the 1,000. Okay? It really does make it easier. I would recommend watching the video from the other class. I did do it this way in the other class from the beginning. Maybe that'll clear it up, or rewatch this. Now, we're not done though, guys. This was the easy part, believe it or not. Now we gotta do the cubic part. Okay, we still have to do the cubic part. So currently we got rid of milligram, we got rid of gram, and we're currently in kilogram, which is what we want. But now we need to go from centimeter cubes, or centimeters cubed, to meters cubed. What units are cubed again? Remind me. When I hear units cubed, say. What is it? 3, good. It's the third power. Now, when I hear cubed here, am I talking about length, area, or volume? Volume. If I see squared, area. If I don't see anything, it's length. Again, if I measure 5 meters across the room as a length, if I measure the room as 5 by 7, I would say it's 35 square meters of area on the floor. If I measure 5 by 7 by 6, I would do 5 times 7 times 6. What do we got? 210? 210? 210 cubic meters. Again, volume is cubic. So right now, this is a volume we're converting. Again, this is a volume. Now, with that said, I have centimeters cubed. So normally I would say centimeters are on the bottom, so where do I put centimeters? On the top. So stay with me here. My next conversion. Centi means what? Raise your hand. Prefix-wise, Charles. Hundred. So give me in scientific, what does it mean? 10 to the what? Help them.
10 to the negative
10 to the negative 2. This is where the memorization comes in, okay? So if you didn't know it, memorize. Centi means 10 to the negative 2, which is 100. Okay? Look in your notes, flip that for you. See your notes. Centi means negative 2. Look at it again. Okay? Again, guys, centi means 10 to the negative 2. Therefore, when I put a meter down here, I need to also put a 10 to the negative 2 here to balance out the prefix centi. And then whenever there's nothing, you put a 1 on top. Yes. Again, just to reiterate, I see your hand, 1 sec. When I see centi here, the meters kind of cancel each other out, but this centi is overpowered. We need to balance it with something. Since centi means 10 to the negative 2, we put this 10 to the negative 2 here to balance out the centi. And we're done with this conversion so far. We'll take a look at the cubic in 1 second. Charles, you had a hand.
I understand why you did the 1 over the 10 negative 2, but how come on other conversions with grams to milligrams, because the 10 over negative 3, how come you didn't put the 1 on top?
Okay, because, yes, it was flipped. See the millis down here for this one? So we're missing the 10 to the negative 3 up top. Whereas here, the centi's up top now. So we're missing centi down below. Remember, Charles, this is a balance. It's really the number 1. So when I see centi, I know that I need to balance centi with something. And centi really means 10 to the negative 2. So since the centi's up top, I put the 10 to the negative 2 down below.
So what I thought I was going to be on top of it.
Exactly. It's going to change depending on the scenario.
So it's not what the units are.
That's why it's called dimensional analysis. It depends on the location of the units. Next, one more step to go here. I have centimeters cubed, right?
Yeah.
But I only have centimeters here. I want to get the meters cubed, but I only have meters here. So what do I need to do to this whole entire conversion factor? Good. Raise it to the 3rd power. We did this one real quick the other day. I mentioned it. Again, we have centimeters cubed, where we started with, all the way over here on the left. We only had centimeters here, though. We want to get this to be centimeters cubed, so we got to cube it. And when we cube this, take a look what's going to happen. This will become 1 cubed centimeters cubed. This will become 10 to the negative 2 cubed meters cubed. And now look at my units. I want meters cubed. So when I raise this to the 3rd, this is still going to be 1 to the 3rd when I raise it, right? But this one will become 10 to the negative 6. Again, because it's negative 2, and when you raise a power to a power, you multiply those powers. Again, that's algebra, remember? Power to a power, multiply the powers. So with that said, we have to actually convert this now. All right, so in the next line, here's what I'm going to do. I'm going to write down just my numbers, because my centimeters cubed are gone with this. And right now I'm left with kilogram per meter cubed. That's what I have right now. And that's the units that I wanted in the beginning. Kilogram per meter cubed. So with just that said, let's write our numbers. We've got 5.14 times 10 to the 4. Nothing on the bottom, there's just a 1, so leave that. Next, 10 to the negative 3 up top. Nothing on the bottom, it's still just a 1. I'll put the 1 as a placeholder, so we're all clear. The next line, I've got a 1 up top, and a 10 to the 3rd down below. And the final line, I've got a 1 up top, and Kareem, again, remind me what's on the bottom now? Good, 10 to the negative 6. Again, it's 10 to the negative 6, because this cube gets distributed. There's a cube there, and this becomes cubed also. We can get rid of that little 3 up there now, and we're good to go. Negative 2 times 3 is what gives me this negative 6 down here. At this point in time, we're just going to multiply through. Charles.
So all the bottom line is
All the bottom line is?
meters? No meters?
Well, no. Now what we want to do, Charles, is look and see. We had kilogram left over after we canceled. So we have kilogram. In the bottom we had meter, but it was cubed, remember? Because we cubed this, so it's over meter cubed, and that's what we wanted to get.
Okay,
If you look back at that.
so we're done converting now, it's just the multiplication.
Exactly. We finished converting when we got to here, and now we're just multiplying and tacking on our units. Okay?
Is there any way for you to, like, for the 10 or negative 3 and the 10 to the third, can you cross
Yeah,
out?
and that's what I'm gonna show you now. Good, Emmett, that's the next step. So Emmett made a good point. There are ways next, which is what we're gonna do to cancel stuff. That's what I wanna do here. So, let's go ahead and take a look. This is 10 to the third, correct?
Yes.
This here is 10 to the negative third.
Yes.
I can move them. I can move them, it doesn't matter. So if I move this one up top, if I move this up top, it'll make it a negative 3. Or if I move this down below, it'll make it a positive 3. Remember your algebra rules here, okay? I know, they were a while ago. So here, we gotta move this one up top. Because your general rule was that if you raise a variable to a negative exponent, it's really 1 over the positive exponent. Yes, exactly. I'm going to bring this up and I'll show you why I thought of this, and I'll explain. You can do it any way you want, but there's easier ways and there's harder ways. The easier way is to move this up top. Make this 10 to the negative 3 up top, get rid of it down below. Okay? What does this become now, up top, right here, these two?
They cancel each other.
10 to the negative 6. Again,
Can you cross out?
these two, don't they become 10 to the negative 6?
Yeah.
Wait, so
Because
is
you
that what we could
add-
have done right at the beginning?
No, Helen,
No.
don't say that
We
stuff.
couldn't have done any of this in the beginning.
Yeah, but.
It happened to work out that these are
It's
canceled.
negative 6.
Just bear with me, Helen. Hold your
That's
pressure.
not it, that's not true.
Hold on a second, please, because you're confusing people and we are on a flow here.
Okay, no one wants
So,
to debate.
10, I'll let you talk in a minute. Please just
Okay,
listen.
sorry.
10 to the negative 3, 10 to the negative 3 become 10 to the negative 6 here. That's a negative, the board's off. Now, what you'll notice is that it cancels with the one on the bottom. That's why I moved that up top. Because I saw that if I could get this to be negative 6 up top, and this is a negative 6 down here, it turns out that they cancel. So in the end, when we're converting from milligram per cubic centimeter to kilogram per cubic meter, it turns out that it's actually, they all cancel. And it's the same number we started with. Complete coincidence based on the units. Again, if it had been, instead of centi, if it had been milli, this would not have worked this way. Okay? It's a coincidence that this 10 to the negative 6 cancels with this 10 to the negative 6. It just happened to work out. Are we clear on that?
Yeah.
If it had been milli, it might not have canceled.
Okay, so I see why you flipped it, but didn't you said that, when you times multiply exponent to exponent, I mean, in multiplying just, shouldn't that be negative 9 or positive 9? Because up there you did,
Up here, we raised a power to a power, which is looking like this. A to the B to the C, as opposed to A to the B times A to the C.
okay.
These you add, these you multiply. Okay? So at the end, it turns out that our numbers end up canceling. And we end up getting the same exact value that we started with. But there's no way you can predict this. Again, you can't just say, oh, I would have known that it happened. You can't do that. You have to go through the steps, especially because it's cubic. When it's cubic, you got to remember to cube that conversion factor. Now, follow-up question for you. Had this not been cubic, had it been squared, what's the only difference in the problem? Instead of cubic centimeters to cubic meters, if it had been square meters to square centimeters to square meters, Charles, what would the difference have been?
Would you have to change the last part of the problem?
Which part of the problem?
The last conversion to the centimeters?
Good, so instead of a 3 here, what would this have been?
It would have been 2.
Good, because again, if it had been square units in our beginning, again, I'm saying, had this been squared right here, and this been squared right here, this would have been squared right here. And thus we would have gotten a different answer. Okay, so it is very important that you actually perform the steps.
Wait, if I was doing it the way, like not even the way, like if I did it the way you were doing it, that we just did it, I definitely would not have thought to move up that 10 to the third and make it negative.
Okay, and if you didn't, that's fine. If you didn't think to move this up, watch what would have happened. 10 to the third, 10 to the negative 6. These would have reduced to 10 to the negative third. And then these would have canceled. Again, positive 3 and negative 6 would have reduced to a negative 3. And then you would have had a negative 3 and a negative 3 cancel. So you'd have still gotten the same answer.
Same answer.
Yes, so that's fine. If you had multiplied these, you'd have gotten 10 to the first, absolutely. Then down here, you would have gotten a negative 3. Then when you do 10 to the first over 10 to the negative 3, you know you have to do 1 minus negative 3, because when you divide, you have to subtract, which becomes 4. So no matter what, you get the same answer. It's up to you to choose the method you're going to take. Okay? All right. If you're still having trouble, again, I put up a video on dimensional analysis on section 1-3 from the other class, where I did a lot of this already also. You can watch that one too to help. Maybe revisit this one. One other thing we do want to do still. Okay? I'm going to give your quiz out in a minute. We might not have time to go over it. But I want to go over something for Monday for your lab. So again, on Monday, what you're going to bring in is a cylinder. That's what you really need. And a pencil, obviously. Okay? A cup, slide short. Cylinder, cup. Now, don't pack up, guys. Do not pack up, whatever you do. Draw yourself an XY axis, please. Notes, in your notes, in your notes. We're going to do a lot of graphing this year. A lot of it. Get used to graphing.
Me too.
I recommend that you get some graph paper that has holes in it and put it in your binder so that whenever you need graph paper, you can just access. Okay? Now, I'm only going over this because it's something that I thought was learned in Algebra 1, but when I asked the math department, it wasn't covered. So I want to make sure we're clear so Monday there's no confusion. I might take another minute after you go, so bear with me. Now, if I had a set of data and I plotted the data, and say it looked like this. Okay? There's my data. Now, I didn't ask a question here, hold on. If I wanted to fit a function to this data, what type of function might this data be? Say.
Positive function.
Positive, and what type? Because it's increasing, good. It's going to be linear, quadratic, cubic, exponential. What might it be?
Linear.
Probably linear. Why? Caroline?
I just guessed, to be honest.
Okay, I would say linear because remember, quadratic looks like this, like a parabola, or like this. Cubic looks like this. Okay? All right, then I'm giving you some new stuff. Again, I'm trying to access prior knowledge. I
What's
didn't know.
the second one called?
This is quadratic. It can be either one. Okay? This is usually a quadratic. This is cubic. This is exponential growth. If a function looks just like this, it's a linear function. You definitely did quadratics, which were parabolas, in Algebra 1. It's a topic that is in all Algebra 1.
We just didn't grab it.
Okay,
So that's.
that's unfortunate. Okay, now, hold up. Again, guys, give me another minute. Here, if I were to fit a line through this data, and that's a little, ignore that little curve there, that's just the board being screwed, the board's messed up here. If I were to fit a line through this data, we call that line a line of best fit, or a best fit line. Now, on your lab on Monday, you're going to have data, and you're going to plot the circumference versus the diameter, and you're going to notice that it's going to be a linear fit. Now, with that said, you're going to also be asked to find the slope of this line. The slope of this line. When you find the slope of a line, remember, delta y over delta x. Okay, we remember delta y over delta x?
Yeah.
Now, if you remember delta y over delta x for slope, you need 2 points. Okay, you need a point in one spot and a point in the other spot. I'm knocking you in for 1 second. A point in one spot and a point in the other. Now, in your lab on Monday, you don't use the data points to find the slope. You use some points on the line. So you pick a point at the end, you pick a point in the beginning. You give it a coordinate. Let's say this is 1, 2. Let's say up here this is 10. This is 15. This data point would be 15, 10. This data point would be 1, 2. And remember, slope equals delta y over delta x. So it would be your change in y,
On Monday.
10 minus 2, over 15 minus 1. You're going to have to do this on Monday. So if you haven't done best fit line, okay, maybe over the weekend Google best fit line, slope of best fit line to become familiar with. Okay? You have homework this weekend. It's on Moodle. Okay, it's on Moodle. I can put it up right now if you want to sit. You're welcome to go. I'm not going to hold you any later. It's on Moodle. If you want to write it down, I'll put it up right now.
Caroline, take a
1 second to check, okay?
Just trying to help the sister out. Wait, is she gonna yell at me?
Yeah, I'll guard you.
It's literally below my body.
Can you pull that curtain back up?